There is no towering launch gantry, no vertical rocket standing on a concrete pad, no roaring flame trench carved into the ground. Instead, there is a runway, an ordinary-looking strip of asphalt stretching toward the horizon. At this spaceport, rockets do not rise from the ground. They take off like airplanes. The United Kingdom is building a spaceport designed around horizontal rocket launch, a system where rockets are carried into the sky by aircraft, released at altitude, and ignited in midair. It looks less like a traditional space center and more like a futuristic airport. This approach challenges a century-old assumption about how rockets must leave Earth, and it represents a quiet attempt by the UK to claim a place in the rapidly growing commercial space race. The United Kingdom is already one of the world's largest producers of small satellites. British-built satellites support communications, Earth observation, navigation, weather forecasting, and national security operations. Dozens of UK companies design and manufacture spacecraft every year. Yet almost none of these satellites are launched from British soil. Instead, they must be shipped overseas to launch sites in the United States, Europe, or other countries. This dependence creates delays, increases costs, and places critical infrastructure at the mercy of foreign launch schedules and regulations. For a country that relies heavily on space-based services, this is a strategic vulnerability. Independent access to space is increasingly viewed as a matter of national sovereignty. If a nation cannot launch its own satellites, it cannot fully control its own space capabilities. Beyond security, there is also economic pressure. The global small satellite launch market is expanding rapidly as companies deploy constellations for broadband internet, Earth imaging, and scientific research. Governments around the world are competing to attract launch companies, manufacturing facilities, and investment. The UK does not want to remain merely a satellite builder. It wants to become a launch nation. Building domestic spaceports, especially ones that can operate like airports, is central to that ambition. The goal is simple. When a British satellite is ready, it should be able to launch from Britain. Horizontal launch is built around a simple but powerful idea. Rockets do not need to start their journey from the ground. Instead of igniting on a launch pad, the rocket is attached to a large carrier aircraft, which takes off from a conventional runway and climbs to high altitude. Once the aircraft reaches the desired speed and height, the rocket is released beneath the plane or from its wing. Only after separation does the rocket's engine ignite, propelling it the rest of the way toward space. This method offers several advantages. By starting above much of the atmosphere, the rocket avoids some of the thick air resistance that vertical rockets must fight through at liftoff. The carrier aircraft also provides an initial boost in speed, reducing the amount of fuel the rocket needs during its early flight phase. From an operational perspective, horizontal launch allows space missions to be prepared, fueled, and inspected inside hangars, similar to aircraft operations rather than being exposed on open launch pads. The concept is not theoretical. Variations of air launch have been tested for decades, including the Pegasus rocket system developed in the 1990s. More recently, companies such as Virgin Orbit used a modified Boeing 747 to demonstrate that orbital-class rockets could be deployed from aircraft. Although some early commercial attempts have struggled financially, the underlying physics of air launch remains sound, and new companies continue refining the approach. For the UK, horizontal launch offers a path to space access without building massive vertical launch complexes. It turns spaceflight into something closer to aviation than traditional rocketry. The United Kingdom's primary horizontal launch site is Spaceport Cornwall, located at Cornwall Airport, Newquay, on the southwestern coast of England. Rather than constructing an entirely new facility from scratch, planners chose to adapt an existing airport with a long runway originally built for military aircraft. The runway at Cornwall is over 2.7 kilometers long, capable of supporting large carrier aircraft carrying rocket payloads. The location also offers direct access to open ocean airspace over the Atlantic, allowing rockets to be released along safe flight corridors away from densely populated areas. Hangars, fueling systems, mission control facilities, and payload processing areas are being integrated into the airport environment. This allows satellite customers to prepare spacecraft, integrate them with launch vehicles, and conduct final checks within a controlled setting. The choice of Cornwall reflects the broader philosophy behind horizontal spaceports. Instead of isolating space activity in remote desert ranges, spaceflight can be integrated into existing aviation infrastructure. In practical terms, Spaceport Cornwall looks more like a specialized airport terminal than a traditional space center, which is exactly the point. Rockets built for horizontal launch are fundamentally different from the towering boosters seen at traditional spaceports. They are smaller, lighter, and optimized for carrying compact payloads into low Earth orbit. These vehicles are primarily designed to serve the rapidly growing small satellite market, where spacecraft often weigh only a few hundred kilograms or less. Instead of lifting massive space station modules or crew capsules, these rockets typically deploy Earth observation satellites, communication spacecraft, scientific instruments, and technology demonstrators. This market favors frequent launches, flexible scheduling, and relatively low costs rather than extreme lift capacity. Several UK-based and UK-affiliated companies are developing rockets tailored to this role, including lightweight launch vehicles designed specifically for air launch or short runway operations. These rockets are built to integrate quickly with carrier aircraft, minimizing ground processing time and allowing rapid mission turnaround. The focus is not on building the biggest rocket. The focus is on building the most responsive one. Traditional spaceports are dominated by massive fixed infrastructure, launch towers, flame trenches, lightning protection systems, and specialized fueling facilities that can take years to build and billions of dollars to maintain. A horizontal launch spaceport looks nothing like this. There are no permanent launch pads, no vertical integration buildings, no blast zones carved into the ground. Instead, the core infrastructure consists of runways, hangars, control rooms, and fueling stations, the same elements found at large airports. This dramatically reduces construction cost and environmental footprint. It also allows spaceport facilities to be expanded incrementally, adding new hangars or support buildings as demand grows, rather than committing to enormous upfront investments. In operational terms, it also changes how spaceflight feels. Launching a rocket becomes closer to dispatching a specialized aircraft than conducting a monumental launch event, which signals a deeper shift. Space is slowly becoming an extension of aviation. Horizontal launch offers a combination of flexibility and efficiency that traditional vertical systems struggle to match. Because rockets are carried by aircraft, launches are less constrained by fixed pad availability. If weather is poor at one location, the aircraft can simply fly to a different area with clearer skies before releasing the rocket. This mobility dramatically increases launch opportunities. The aircraft also lifts the rocket above the densest layers of the atmosphere, reducing aerodynamic drag and allowing the rocket to use less fuel during its initial ascent. This improves efficiency and can slightly increase payload capacity compared to an equivalent ground-launched rocket. From an operational standpoint, horizontal launch enables faster turnaround times. Rockets can be integrated with payloads inside hangars, protected from wind, rain, and salt air. Ground crews can work in controlled conditions, speeding up processing and reducing delays. Perhaps most importantly, horizontal launch lowers the barrier to entry for new spaceports. Countries do not need massive launch complexes to gain access to space. They need runways. Despite its advantages, horizontal launch is not a universal solution. Payload capacity is significantly smaller than vertical rockets. Carrier aircraft can only lift a limited mass, which caps the size of the rocket and the satellites it can carry. This makes horizontal launch unsuitable for heavy payloads, crewed missions, or large spacecraft. The system also adds complexity. Instead of managing a single launch vehicle, operators must coordinate both an aircraft and a rocket. Every mission involves two aerospace systems working in perfect synchronization. Economics remain a challenge as well. Some early commercial air launch ventures struggled to reach sustainable launch rates, showing that technical feasibility does not guarantee business success. Horizontal launch works best as a niche solution for rapid, small payload access to orbit, not as a replacement for all rockets. For decades, spaceports looked like fortified rocket fortresses: concrete, steel, fire. The UK's horizontal spaceport represents a different philosophy. Spaceflight that begins on a runway, rockets that start their journey like airplanes. A future where reaching orbit feels less like an event and more like a departure. This is not about replacing traditional rockets. It is about expanding the ways we leave Earth. Because the road to space may no longer point straight up. It may start with a takeoff roll.